Hey guys. So we're back today. We're on analysis, unit 7, lesson 6. We're going to be solving exponential and log equations. And some of the equations we're going to be dealing with are going to be equations we're going to see in calculus. Okay. So yesterday we solved exponential and log equations where we had to, really use our properties. And hopefully you got that experience on your homework, practicing all the different types of things that happen when you simplify using your properties. Today, we're going to practice some more log equations. Some of them will deal with just using properties, and some of them are going to be dealing with different types of situations that we're going to see in calculus. The most important thing for you to understand, when you look at a problem, think about what you know and what you need to solve the equation. This is going to be really important, knowing where you have to go. I'm not going to be there to guide you through how to solve equations, and you have to be able to see certain things. So for example, in example 1, when we look at that, okay, first off, I see that the variables in the exponent in each piece of the equation. I have a fraction on one side and just a term on the other. That's okay. But what I really think is important to notice is that I've got an 8, a 4, and a 4 as a base. Okay, so the best thing to do would be to rewrite each term with a common base. So you think to yourself, what's the smallest base that I can rewrite each of these bases with? And that number would be 2. So you would go ahead and you would rewrite the 8, the 4, and the 4 as some power of 2. 2 cubed raised to the 2x plus 4. 2 squared raised to the x minus 3. 2 squared to the x plus 5. And now you're going to use your exponent laws to rewrite this. When you raise a power to a power, remember you multiply. 2 raised to the 6x plus 12 over 2 raised to the 2x minus 6, 2 raised to the 2x plus 10. It's easy to make a mistake here, so I'm trying to go slow so I don't make any mistakes. And now I have on that left side there, I'm dividing like bases. When I divide like bases, I subtract their powers. 2, so I have 6x minus 2x to the 4x, 12 minus negative 6 plus 18. And now that I got down to this step where I have each base simplified, I go ahead and cancel my bases and I set the powers equal to each other. And at this point, it just becomes a regular old equation that you solved in your old algebra classes. So I have 2x equals 10 minus 18, negative 8. And x is going to equal negative 4. And if we remember, when the variable is the exponent, it's okay to get a negative answer, and we are good to go. Okay. In the next example, think about what you know already. Okay. I know I'm scared when I see an E, but that's going to be okay. I see a fraction on one side and a number on the other, but only one term has a variable. Okay, so this is a little different than the last example. So I may start by putting this over a 1 and cross multiplying. So I'm going to have 20 times 100 minus e to the x over 2 equals 500, right? I'm just going to cross multiply. I'm going to distribute to get that out of the set of parentheses. 2000 minus 20 e. Oh, I could have just divided. That's okay. I already started it this way, so That's all right. You could have just divided that 20 over. That might have been easier. Now I'm going to subtract. But again, it doesn't really matter. Negative 20 e to the x over 2, 500 minus 2,000, negative 1,500. And remember now, I'm just going to do this in a different color here. We want to isolate this base. Remember that yesterday we talked about, like, or the day before? No, it was yesterday. Okay. Don't worry how big or small or complicated things lift. You just want to get, that base by itself. So I'm going to divide by negative 20. E to the x over 2 equals negative 1,500 divided by negative 20. I got 75 when I did it the first time. Let me try it again just to make sure. Yeah. And now at this point, when you have a number equal to a number, now you can put logs on. Okay. So that was a lot of work just to get it to a point where, oh, now we're going to just, try to start to solve it. So I have ln e to the x over 2 equals ln of 75. Well, remember that x over 2 can come out front. And the nice thing about this, when you use ln to solve, remember ln of e is really what? Ln of e is 1, so that just cancels. So I have x over 2 equals ln of 75. So x is going to equal 2 times ln of 75. Which is 8.635. Okay. And that's it. It is a lot of work, but this is the jump that we're making before we get to our calculus class. Okay. This one should be fairly easy for most of you. Okay. Hopefully you guys know where to start. This is just like one of the questions we did yesterday. I look at this operation in between. It's a minus sign, so I'm going to divide. The reason I chose this problem is this particular setup. What happens, a lot of people freak out over it. That's why I wanted to go over it. Now I have a log equal to a log. I'm going to cancel those logs. And I just wind up with x minus 3 over x plus 1 equals 1/2. All you have to do here is cross multiply. 2x minus 6 equals x plus 1. So x is going to equal 7. Double check that it doesn't make any of the arguments negative. And since it doesn't, we can keep this as an answer. If it made either one of those negative, of course, you would be rejecting it and there would be no solution. And remember, that is okay. That does happen. In our next example, okay, so I'm not quite sure how to start this one. I have a log on one side and something on the other. So the first thing I'm going to try, just to try, is I may try to rewrite this in exponential form and see what happens. 10 raised to the x cubed minus 3 equals x. Okay. And this is going to give me a problem because I can't isolate the variable. Okay. If I was to put a log on each side, I'd wind up with a log in, a variable on two different sides of the equation, and this can't happen. We can't do this. So this is going to be like our first situation that we see that we're going to have to use our calculator. There's going to be times that you're going to have to go to your calculator. And you have to recognize sometimes when those times are. And this particular situation is one of them. So I have an X after a log and I have a freestanding X. So that most likely will require a calculator. So basically when we do something like this is we want to get everything to one side. Log base 10, I really don't need to write that base. Minus x cubed minus 3 plus 3 equals 0. Okay, so I'm going to start by just getting everything to one side, and then basically I'm going to plug that in my calculator. Okay. So what I'm going to do is I'm going to use the second trace feature on my calculator. So remember, log base 10 is the same as just hitting the log key on your calculator. But what you have to be aware of is you have to close off that parenthesis after you're done. So I have log x. I'm going to get out of that parenthesis minus x cubed plus 3. Okay, so that's my equation. So we get everything to one side. Right, it's equal to 0. Then we put our equation in y1. Now we're going to hit the graph. And I'm going to use my second trace feature. So I'm going to second trace. And I want to find the 0. That's what I'm looking for. I'm looking for where it crosses the x-axis. And left bound, remember, this is where, oh, my picture's in the way for you. But the calculator up on top says left bound. So we're going to move, and I have to find my little cursor. Not quite sure where that is. I'll move to the left side of the x-intercept, and I hit enter. Then it says right bound. I move to the right side of the x-intercept, and I hit enter. And my 0 should be at 1.4685. So my 0, or my solution, is 1.469. And that's just one that you have to use your calculator. Let's just finish off our steps here. We have to remember to do our left bound and our right bound. And you'll see the zeros will show up on that bottom thing down there. Okay. Sometimes in the future, sometimes you're going to have to be able to like say, where is the graph above the x-axis? Where is it below the x-axis? But those are things we'll talk about later on in the year and in your calculus class. Now, in example 5, okay, in example 5, I'm looking at this. Okay, this is a type of situation that when we are in calc, okay, this is going to show up quite often, and this is going to be one where you're going to have to recognize that this is going to be an algebraic. We really don't always jump to the calculator with these. Okay, it looks like a mess, but basically, if you look at these, each of these terms has an e to the negative x. So we're going to factor that out. Okay, we're going to hopefully start to recognize that we can factor that e to the negative x out, and we're left with x squared plus 3x is equal to 0. And now when we have it in factored form, we can set each factor equal to 0. And now remember, if you forget that e to the negative x can never be 0, and you turn around and you start ln'ing it, you'll wind up getting an error. So even if you go through the motions, you'll get an error. This can never, an exponential equation can never equal 0 unless we have a vertical shift. And for this factor, x plus 3, so x is 0 and x equals -3, and these are going to be true solutions because it was an exponential equation to begin with, and that's okay. And question number 6. Okay. Question number 6, we're going to want to look at this for a couple seconds here and realize, okay, that the first place we may want to start is by cross multiplying. Whenever you have something equal to 0, a fraction equal to 0, you might want to start there. And if you remember correctly, when you cross multiply, it's really like setting the numerator equal to 0. Now, there's going to be a lot of times that you're going to be allowed to use your calculator, but you can't always jump to the calculator. Sometimes we may have to algebraically figure things out. So I want to help you this year to see things that, even though they look scary, they're not. If you think about this, if I bring this ln of x over, I have 1 is equal to ln of x. And since I can't stand to look at things in that form, I'm going to rewrite it. This still looks scary. But remember, whenever you have a simple expression like this, if you want to, think about it like this and rewrite it in exponential form. E to the first power equals x. That's our little trick that we can do. So x is e, right? Our solution is really e, which is approximately 2.718. Either answer would be acceptable. A lot of times in calculus, we'll get like 1 over e as an answer or e squared as an answer, and you just leave it in terms of e. So in that case, either answer would be acceptable. And don't worry or don't be concerned. I will let you know on your test whether or not you can go to the calculator or I want to see the algebra, okay, with these types of situations. In this last example, I kind of wanted to go here mainly for your like SAT and your ACT work, because a lot of times they want you to be able to do things where you're solving for a variable, but you're not winding up with a number. You're just winding up with an expression. Okay, so we want to be able to figure out, okay, our main goal here is we want to get that x by itself. Okay, so it doesn't really matter that we don't have numbers. Where is the variable? It's attached to a base. So we isolate our base. I'm going to rewrite this. I don't want to write on my problem. So I'm going to divide each side by a. So I have e to the bx equals y over a. Now that I have my base isolated, I can ln each side. Okay, it's just like their numbers. Bring that power down in front. Bx ln e equals ln of y over a. That ln of e, remember your property, ln of e is just 1. I'm going to divide by b, and x is going to equal ln of y over a divided by b. We could even go a step further because I can kind of rewrite this top here. I can use my properties of logs, and you guys should be able to see stuff like this. Ln of y minus ln of a all over b, because that's a little bit nicer to look at. Okay. They're equivalent. They're both the same thing. So either answer, I mean, I would accept either answer, but if it was like a multiple choice on the SAT, you'd have to be able to pick the best answer. So you should be able to do that manipulation. Okay, so again, please practice your homework because it gives you the practice you need to know the difference and when to go to the calculator, when you should fiddle around with algebra, so to speak. So make sure you do the practice that you need to. Thanks, and see you soon.